Welcome to another video on Blind 75 problems, and today we're going to solve the validate parentheses problem. This problem relates to the overall thematic group known as stacks, and this is probably the only problem related to that. And this problem is asked almost in most interviews, uh, whether by phone or otherwise. This is one of the most commonly asked problems in coding interviews. So how does when we talk about this problem, validate parentheses, what do we need to do in this particular problem? So simply speaking, in this problem, we need to identify. We need to we need to do three things. Oh, sorry, let me remove that. We need to do three things here, right? We're given an input string s, and we need to return true, which means it's valid only if it meets the following three conditions. Every open bracket must be closed by the same type of close bracket, right? That's number one. Open brackets are closed in the correct order, so their order is correct. And number three, every close bracket must have a corresponding open bracket of the same type. All right. So how do we explain this? So number one requirement is open bracket is closed by the same type of bracket. So we're going to presume there are only three types of brackets here. This bracket set, this bracket set, we call curly brackets, and then we have square bracket sets, right? So only these three brackets are there, and they are opened and closed like this. Each open and closed by the same type of bracket, right? Then we need to make sure that the order is correct, right? So how is the order going to be correct? Again, like for the first point, every square bracket must be closed by a square bracket. Every curly bracket must be closed by a curly bracket. Every circular bracket must be closed by a circular bracket, right? Now that we understand that, what is the second thing we need to understand in this problem? Open brackets must be closed in the correct order. So presumably, if we have, let's say, an example here, let me pull that up. Yeah, this one should suffice. Let's bring it over to our whiteboard and go over this problems to understand situation number two. So with that coming over here, let's pull it up here, drag this to make it bigger. So number two, we need to every open bracket must be closed by the closed in the correct order. What do we mean by that, right? So let me pick out my pen, a different color. Yeah. So here you can see we have the last bracket to open is the curly bracket, but immediately after that, it is closed as well. So the point here is, and then we have the square bracket opening itself, and then the square bracket closes is the second bracket that closes itself, and the opening bracket here is the circular bracket, but the last bracket here is the circular bracket. What do we mean by that? So a bracket cannot be closed like this in the order. Supposedly this was, let me use darker, bigger color. So and make this magenta as well. So potentially we have a bracket like this that opens it, then the square bracket, and then a curly bracket, right? So potentially, if the second point hopes that we would track that this bracket is not closed by a circular one, then a curly one, and then a square one, right? This doesn't match, and this creates problems because the circular bracket here is being closed by the square bracket. The curly bracket here is being closed by the square bracket, and the curly bracket opening here is being closed by a circular bracket. This is wrong. So what we need to make sure is our brackets are closed in the appropriate order, with closing the uh, appropriate bracket itself. So that's point number two. So what is point number three? What's the third point we need to focus on in this particular problem? And that is every closed bracket has a corresponding opening bracket. So every bracket that we're closing must have the same type of opening bracket, right? What do we mean by that? So if we write point number three here, you understand that uh, if we open circular bracket, we can't leave this open ended basically. So if we have after that we have a square bracket, and then we close the square bracket, and that's it. This is wrong because this circular bracket must be closed for it to be valid. So that is the third point. Now that we understand what we need to do in this problem, how do we solve this problem? Like, what's the logic in solving this problem? Let's write a simple problem here. So let's write circular bracket, square bracket, curly bracket, close the curly bracket, square bracket, and circular bracket. We have these brackets over here, right? So how do we test these brackets out? From our conversation earlier, we understand first thing, we don't need to focus on the opening brackets that much. What we need to understand focus on are the closing brackets, right? So if we find a closing, let me change the color so that there's this little bit different color we use here. Let's use let's use cyan here. So if we have a closing bracket here, right? This is the closing bracket. So this closing bracket here, if we find that, we can only validate this to be true if we can find a similar uh, if we can find a similar uh, uh, you know if we can find a similar close opening bracket for this, right? On the say next to it, right? So once we find a similar closing bracket to this, we cut this out. All of this is cut out, right? And that means we're good. We move on to the next step, this of validating the string, right? Use another color to deal with the other bracket. So let's use green here. So then we identify this square bracket, closing bracket, right? All right, we found that. But to test whether this string is appropriate or not, we need to find a similar square bracket. We have already deleted the curly braces from our data, right? So we check next to this square bracket if we have a bracket that is curly. We have that, so we cut this out as well, and this one here as well, right? Let's find another color, and let's use blue over here, right? So now we find the closing circular bracket. That's the next thing we've identified, right? This is basically how our logic will work for this problem. So now that we have that, we need to find if next to it we can find something that is not something that opens the that opens the, that's an opening circular bracket, and indeed we do, which means cut this out and we cut this as well. What does this mean? This means we have nothing left in our string, so it validates to be true. It meets all of our conditions that we discussed, right? So this becomes true. But supposedly, if we had something like this, circular bracket, curly bracket, square bracket, curly bracket, and circular bracket, right? If we had something like this, right? Let's test the first one here using the cyan color, right? That was our first color. So we identify a closing curly bracket, right? But next to it, we don't find that bracket. That's an issue. That becomes an issue for us. We can't delete this. So this entire unit stays as is. And because we haven't eliminated anything within this, this becomes false in the validation. That's our logic to validate these values here. And that is basically how our logic would work in validating these values. So with that out of the way, now let's focus on how we can potentially solve this problem, right? So we're going to use the stack, system to solve this, because on top we can remove anything on the top of the stack if it is a matching bracket. So we pop it off. Otherwise, we basically can't do that as easily. So with that in our mind, let's start coding this. So let's bring in our first pseudocode, uh, which helps us code this problem out. So for our first pseudocode here is dictionary to hold mapping of closing to opening brackets. Oh, on that point, I think I missed one important concept here. We're doing all this mapping, matching of closing with opening brackets. How are we doing that? We're doing that using something called, let me use another color here. We're using that to using something called hash maps. So we have hash maps that have built relationships between these three brackets. So we have simply speaking, we have three types of brackets, right? So in each case, we have three cases in our hash map that map this relationship, and these relationships within this hash map is basically helping the computer make the judgment whether we can find a closing bracket or not. So how do we do that, right? Do that basically uh, if we have, let's say, a closing circular bracket over here, right? We're going to use hash maps to build a relationship between this closing bracket and the opening bracket. Right? Similarly, if we have a square closing bracket, we check whether this square closing bracket, has as opening bracket. We build a relationship between them. Similarly, with the curly brackets, the closing curly bracket must have a relationship with an opening curly bracket, right? So these are things that we're testing out basically, and every step of the way, this particular hash map is being used to identify exactly what understand exactly basically if there's a relationship between a closing bracket and an opening bracket. So as long as we're able to establish that, we can move on to the next thing, which is start to code this out basically. So dictionary to hold the mapping and closing of the opening brackets, right? So how do we map that? We create a bracket map. We're building this hash map, which creates a relationship between each of these brackets, a closing bracket to an opening bracket, so on and so forth. So let's write that relationship. Closing circular bracket into opening circular bracket, right? Then we write out the next values, which is closing square bracket, curly bracket with opening curly bracket, right? Last thing, closing square bracket with opening square bracket. So that's how we've mapped out the relationship between these problems, these brackets. Next thing is we need to basically have the stack hold the opening brackets, right? So we're going to build the stack first to build the opening brackets. So we open that up now, and we work on the next thing, which is we need to now traverse through the string that is given to us and act on that particular string. So we need to use a for loop to do that. Do that, we write the for loop for char in S. Then we basically check for closing brackets. And how do we do that? If statement, if char in bracket map. Once we have the bracket map, then we need to basically pop the top element from the stack if it's not empty. Otherwise, we use the dummy value of hash within the stack. Then we need to basically write an if statement to uh, if basically if we don't find a mapping for the closing bracket, which is the opening bracket, then we immediately say, basically immediately we say return false, and our function should be done. Because again, like only the moment we have everything removed from the stack, only then, even if it's an empty string, then we understand, hey, this is a validated value. But if it isn't validated value in the sense that we can't find a opening bracket for the closing one, then it means that we immediately know this is false. So we test that, score that out. We're trying to test if the character is not equal to the top element in this case. Then we need to do an else statement to the overarching if statement. And then we append the stack on the jar. After that, we just return not stack. Because if the string is empty, all brackets are properly closed. At that point, this is what we need to return. With that out of the way, we're going to run this code and see if this works out. And both case studies are solved properly. With that, we can solve this particular problem of line 75 regarding stacks. And with that, we're going to wrap this video up and see you on our next video. Thank you.